Welcome back, team. My name is Clint Hoagland, and this is Creating Electronic Music with ChucK. In our last video, we discussed how to control MIDI hardware using ChucK, as well as how to control ChucK using a MIDI controller. In this video, we're going to talk about the instruments of the STK. Now, what is the SDK? The SDK refers to the Synthesis Toolkit in C++, which is an open source library built by Perry Cook and Gary Scavone, which has been developed and maintained since 1995. The SDK contains a bunch of pre-built instruments and effects processors that are meant to be used in C++ programs. This is not a tutorial on how to do that, although that does sound interesting and I may do that in the future. From a ChucK perspective, the reason why the SDK is interesting is that lots and lots of SDK classes are also present in ChucK. This is probably not a coincidence, as Perry Cook was ChucK creator Ge Wang's college advisor when he invented ChucK. Most of the ugens in ChucK are actually SDK classes wrapped in ChucK interfaces so that ChucK programmers don't have to know C++ to use them. Examples include the ADSR ugen, the delay ugen, and the reverb ugens, as well as the wave in and wave out ugens. Additionally, ChucK has ugens wrapping a number of physically modeled instruments from the SDK, and that's what we're exploring in this video. The first thing you'll need to know when exploring these is that you can always look up things on the ChucK ugen reference online at http://chuck.stanford.edu/doc/program/ugen.html. As you can see, there's a link to STK Instrument here, which takes us to the STK Instrument superclass. This superclass itself is not meant to be used in a ChucK script. Much like ChubGraphs, it's meant to be overridden using child classes, and it lists the child classes that are available. Now, I'm not going to go into detail on all of these in this video because that video would end up being like 3 hours long. But I will go into detail on one of them so you can see how to translate the docs into your ChucK script, and then we can explore others in future videos. Okay, so we're going to look at what's called the BandedWG instrument, which WG stands for waveguide in this case. And it says in the docs, this class uses banded waveguide techniques to model a variety of sounds including bowed, bars, glasses, and bowls. For more information, look at a white paper that came out in 1999. Okay, so we're definitely not going to do that. But down here we have the things that will work in the ChucK ugen that is wrapping this SDK instrument. So I have here in VS Code a little test class. I'm just going to launch it right here so you can hear what it sounds like. Right now it's using a sine oscillator, but we're going to switch it over to the waveguide, the BandedWG ugen here in a second. Okay, so that's what that sounds like using the sine oscillator. Now let's switch it to the BandedWG. Save her up, and I'm going to launch it. And we don't hear anything. And that is because the sine oscillator makes a sound by default. You don't need to throw any kind of note on to it to make it go. But for the BandedWG, you do have to. So we're going to stop this, and I'm going to pass a 1 to stk.note on. And the reason I knew this is because it says it right here. There's inherited from STK Instrument is a note on. So let's see if that does what I was expecting. Save it up, and let's launch it and see if we hear anything. Okay, so that was the default state of the BandedWG, which it will say there are a couple of different modes, and Note on appears to do the same thing as Pluck. I'm going to try switching it from Note on to Pluck and see if that sounds the same. I might have to sneeze here in a second. So you'll notice that that has kind of an envelope on it. Let's do it half as fast as that. We'll go down to 250. There's no envelope generator or ADSR applied to this thing. It's got its own envelope characteristics based on the physical modeling. And Pluck was also in that documentation. You can see here, Pluck is one of the things that you can pluck the instrument from 0 to 1 via the pluck method. Now, let's see what it sounds like. I don't want to be in this program. I want to be in this program. Let's see if we set a 0.1. Just much quieter. Incidentally, I think you can actually send it more than 1. I'm going to send it a 2. I was playing with this before. So, yeah, it can actually go a little louder than 1 by setting it more than 1. Now, there, in addition to Pluck, there's also, not this, let's go back to Chrome, yeah. In addition to Pluck, there's also Start Bowing. So let's try that and see what that sounds like. See what that sounds like, just like this. Sounds like nothing. I think, well, I know why that is. Let's switch this down to 0.5. Still nothing. Interesting. 1. Maybe you have to set some of these other things before it'll do something. So there's a bow pressure. Maybe we need to set a bow pressure before we hear anything. So I'm going to set the bow pressure to, let's make it 0.5. Save that up. And once again, I saw that was a thing by bow pressure is right here. We're going to stick it right in the middle. And now let's see what we get if we save that up and launch it again. So now we're hearing something. Let's set it to 0.8. How about 0.5? So it's real quiet. But note that the, let's make this last a little longer. So the envelope on this is very quiet, but the envelope on this is quite a bit longer for bowing. If we make the pressure 1.0, what does it do? So that's interesting, right? So like when it gets to 1.0, the bow pressure causes the physical model to get a short envelope, and I believe that is because that the physical model considers that to be the bow stopping the resonating bar from resonating. And we'll talk about the physical models that exist in this thing in a second here, but let me put this to like 0.9 and see if it still does that. It does. And if we did this as 1.2.0 to start bowing, would we get the same thing? I think there's interactions between these things. So that didn't sound any different. But if I switch this to 0.8, yeah. So it sounds a little different. So So there are 4 different physical models inside the BandedWG ugen, and they're here, and they have their instrument presets. There's the uniform bar, which is the one you get by default. There's a tuned bar, a glass harmonica, and a Tibetan Bowl. So we've been listening to the uniform bar. Let's switch over to the next one, which is tuned bar. And we do that by sending a 1 to stk.preset and spell it right. Save that up. Let's try it again. So because I'm bowing on this one, you get quite a different sound. It's kind of a, you do get that bowed sound. So if I switch this all the way up to a whole second, or 1,000 milliseconds, there's also a stop bowing, and let me just go for 900 milliseconds, and then I'll send a 1.0 to stop bowing. And we can see that here. There's a start bowing and a stop bowing. And let's go for 100 milliseconds, so it's the same amount of time. Now, and let's see what that sounds like. It's interesting because it's very quiet. So let's undo all that. Save that up. So this, once again, is the tune bar. And you can hear that it's not just that the sound gets louder. Sorry, my cat got in here. I'm going to get the cat out of here. One moment. I'm going to pause the video for just a second here. And we're back. Okay, where was I? I want to see what this sounds like if we do it for 2 seconds. So it has actually sort of an interesting, takes a sort of an interesting journey along the way. Let's do it for 5 seconds. It's not just getting louder, the tonal characteristics change over time. Seems like it stops its trip after like 3 seconds. So let's do we'll do 2800. And then we'll stop bowing after 2800 seconds. And give it another 200 milliseconds. And see what that sounds like. So I added some delays up here, just because this kind of thing sounds kind of cool with delays. So let's uncomment all this, and let's see what it sounds like. The tune bar taking the whole trip with the bow. It's got a very characteristic physical modeling kind of sound to it, which I find kind of interesting. Let's see what the other physical models sound like. So this was the tuned bar, and then the glass harmonica is next. Let's just listen to that. Yeah. So if we set, chuck a 2 into this preset, then we're going to hear the glass harmonica. It's got kind of a, how do I put this, like straight to VHS horror movies vibe to it. So let's try the, what's the last one called here? It is called a Tibetan Bowl. Right, all tabbing is not working. All right, so save this up. It's really quiet. I wonder if changing the bow pressure would change it. Like, what if we change the bow pressure to 0.5 in this thing? Gives you really different harmonics. So instead of what I'm going to do here is, instead of just setting it up here, let's set for every trip through that bow, let's change the pressure. So we're going to do math.random to F, and we're going to go from, let's do like 0.1 to 1.0. Let's not do 1.0, let's do 0.8, because it'll just stop if it hits 1.0, and then we'll set that to the bow pressure, and maybe we'll get something kind of interesting. And maybe let's just leave it like this for now. Oh. Typo. So something that I think is useful when doing this kind of thing is you can output these things to the console, right? So I don't know exactly how the bow pressure is interacting with the sound, but in this loop I can access it, and then we can sort of get a sense of how this number is changing things. So very low, halfway up, 6. So around 0.6, they're pretty loud. So you can imagine adding something like that to a chub graph, and you could get a couple of them together, and it might be kind of neat, right? Let's go back to the docs here. There's the amplitude for modes, which is interesting. Let's go back to always having the same bow pressure. But we'll do, what was that thing called? Modes gain. Let's go from a random number for modes gain. And we'll go from 0.1 to 1.0. And we're gonna find out how this is changing the sound. So this is sort of a fun way to explore what's in the docs. This isn't really telling me very much because the note's jumping around a little bit too much. So let's comment out this line, and we're gonna say that we're just gonna say that 48 is note. So it's the same. So we can get the same note every time. I think that's showing us pretty definitively that modes gain thing doesn't do anything for this sound. At least the way I've got it set up. All right, so let's leave that alone. And there's a couple other things that we can play with out here. There is the bow motion. Let's see what that does. It seems like lower values is closer to a pluck. So let's see. Let's just send a 1.0 to bow motion every time. Not 10, but 1.0. And see if interesting. Okay. I don't know what that's doing. Let's see what the bow motion is by default. So by default, your bow motion is 0. And it seems like 1 is a pluck. There was another thing in there that was bow rate, which is bow rates. The attack rate in seconds. Okay. So let's do. We'll do 0.25 to 2 and see if that, and then we'll look in here for the bow rate and we'll see if we can see that happening. That really doesn't seem to make any difference. Let's try it with a different preset. Let's try it with the tuned bar preset and see if we get the same results. Yeah, it seems like not all of these things, although they're in the dock, not all of them seem to be doing anything. All right, I think we're running out of things to try. We tried the Mose gain. We tried strike position from 0 to 1. Okay, let's try that. And this might only make a difference if you're plucking. I don't know. That seems to be the same no matter what. Let's try switching this back to Pluck. And let's turn the speed up on this quite a bit. And see if there's any difference in the way that these sounds sound. Oh, that got to be a. We could turn the delays back off too. That'll sound the same. If the preset's 0, does it still sound the same? Yeah, sure does. So strike position doesn't appear to do anything either. Okay, well, now we know. Yeah, we've tried all the things. So then we just play around a little bit. Let's switch this back to, let's make this maybe 125. And we'll get this back in here. Get rid of that. Turn our delays back on. And this is the, once again, this is the uniform bar. Oh, you know what we can do? Let's do this. That'd be nice. Let's do switch this to random and go to from 0 to 3. We know the preset does something, so we can play with that in our random thing. Love to hear random stuff, right? That's a fun way to play a major 7 chord. Let's try doing this twice. Maybe that'll sound neat. This actually reminds me a lot of some of the sounds on a Dave Smith Evolver, like it's like a wavetable synth. So yeah, that's the BandedWG ugen. In future videos, we'll look into other ugens that are in the SDK. In this video, we introduced STK Instruments and explored the BandedWG ugen. In the next video, we'll explore what we can do with file I/O.